I'm actually really excited about our first speaker here, Vaibhav. So, founder over at Boundary. You might better know him if you're following AI infrastructure. Is it BAML or BAML?
BAML.
BAML. Thank you. So there's a huge, like this morning, I keynoted on agentic workflow, on kind of agentic flows. I think BAML is one of the most interesting technologies out there on the more workflow side of things, and it's just. I don't know, it's a really exciting time, and so I was really happy. I think I actually flew out for this talk too, so thank you, and take it away.
Well, I hope I don't disappoint you, but thank you, Leo, for having me. Nice to meet everyone. I'm Vaibhav. Just to get a scope of everyone that's here, how many of you have never written a line of code in your life? Okay, I apologize ahead of time. This will be a technical talk. My name is Vaibhav, and the thing I want to talk about today is shipping agents. We all see this thing where I was showing some demos in the beginning where like I could take something as much as like a form from Cambodia, and typically if you use an LLM to go do something out of it, it would probably not work. It would feel like a toy. But what if it could work? What if I'm the government in Cambodia, I process millions of these a year, and it pulled out the data in the exact same format every single time I wanted it to? And I did this without any prompting. I did this with an open source model or with Anthropic's model without any fine tuning at all. And check this out. These things down here, these checkboxes turn into Booleans. Booleans are so much more useful than a checkbox. There's no amount of data extraction I'll ever pull it out. I can do something a little bit more. Let's take something real. This is like my thing right here. We spelled my name wrong and the company name wrong. But that's okay. My name's hard to spell. I forgive them. They got the Wi-Fi working for me. That's what counts. And you can see right here, it was able to pull things out. This is all real time happening. How do we build this? How do we go from building something that can go ahead and say, we all know ChatGPT can generate recipes, but doesn't this feel a lot better because I can actually interact with it while it's streaming? Even while it's pulling data out. It now doesn't feel as much like ChatGPT. It's a unique application built just for this. Instead of asking ChatGPT to pull out a resume, it looks like this. What if we could get a resume that looked like this? Every single time. These links are real links. This is the interactive component that comes down to it. How do we go and build these kinds of applications? That's what I want to talk about. We all know real database systems can't fail 5% of the time. Your company shuts down. But we change that one word to another word, and it suddenly becomes acceptable, in fact, celebrated. I think that's not okay. We can't really rely on software that's going to fail 5% of the time. And the reason that this is so hard is because fault systems now have to be fault tolerant. And typically, there's only a few companies in the world that have had to deal with this, bringing 5 nines of accuracy. We got Google out here. We have AWS. We have Microsoft. Everyone else just relies on the backbone of that, expects it to just work, and that's it. But now, every developer that builds an application on top of AI needs to think differently. They need to reevaluate the way they even perceive software fundamentally to be able to build an application that works. And that's really, really hard. Brief background about myself and my co-founder. I worked on the original Microsoft HoloLens team, so we built out some of the tech over there. I worked on Face ID and head of optimization for Face ID, parts of Face ID, and then AR tech at Google. And then eventually I went to a hedge fund, did some weird things over there where I optimized parts of NumPy and Python and other compiler stuff. And my co-founder worked at Prime Video, and I guess the Amazon EC2 logo is not here, but scaled up EC2 to a large amount of systems. A lot of these systems have a lot of fault tolerance built into it. So eventually we decided to go out there and build out Boundary. And I think the best analogy is how we used to do web dev. We used to write websites like this. We don't do this anymore for a lot of reasons, but primarily because this React is much, much better. If you forget a closing slash here, there's no error that happens here. You just find out when you deploy the website because an intern forgot a slash. That is fatal if you're a multi-billion-dollar company. Your website went down because of a slash. React fixes that problem. You forget a slash in React, you can now go get squiggly lines. You get compile time errors, not runtime errors. That means you have a system that is way more robust and reliable. There's a lot of other things. You have like strings being a fundamental problem. State management used to be really hard. I remember when I was interviewing for jobs in 2015 for the first time, making an infinitely scrolling page newsfeed was a hard problem. If a freshman can't do that with Next.js today, you don't hire them for an internship. It's just the syntax we use can fundamentally change the way we approach the world. And most importantly, what React really did is it changed the iteration loop. Back when I was actually writing web dev in string form, you would have to go and spend minutes iterating and navigating to the right page, make sure you don't know what would break. React made it so it's seconds. You go to the editor, you press Control S, it hot reloads just that one component. In general, old web development had low engineering rigor. React brought engineering rigor to a world of engineering rigor. In my opinion, I used to not respect front-end engineering, no, but it is actually hard. But before React, it felt like globbering together strings. After React, it became real engineering that required talent and skills to go build. In general, how many of you have seen agentic code that looks something like this, ever? How many of you look at this code and go, beauty? There's a reason for that. You have almost the same problems as web dev. You have strings everywhere. Context management is really, really, really hard. A model comes out, you can't use it because you're locked into one API you happen to code in. Who knows what downstream effects you have? And then the iteration speed. I mean, we all know how slow it is. In general, it's low engineering rigor. What we really want with agents is we want to marry this idea of expressiveness, but with flexibility. What I love about models is how expressive they are. I can put in anything to ChatGPT and it gives me something useful. The problem is I have code where I can't put in something I want. I need to marry those two systems together. Anyone seen these frameworks? Anyone seen this blog post? If you haven't, go Google it. It's called FE Show Me the Prompt. Turns out the only thing that you really need out of the model is you need a prompt. You put in a prompt into it and it puts out some data out of it. If you're using a framework that doesn't make it possible for you to see the prompt, you can't possibly get the juice out of the model. You can't possibly even know what's actually going to happen. Systems will break in ways you can't predict. Imagine if React never showed you the HTML code underlying. Or imagine a Jupyter notebook made it impossible to see the actual Python code you were running. It would be useless. All these agentic systems that we see that do magic SQL generation show you the SQL query for a reason. Because if you don't see that, eventually it is hard to know what went wrong, or if it's approximately correct but actually correct. The problem is if you're building an AI pipeline and you can't see the prompt, you're living in that world. So let's talk about what it might take. So the thing is, we did something incredibly dumb. We made a programming language. I'll talk about why, but let's talk about what it ends up looking like as a developer and why it does this. I'm going to do live coding. I will try and be fast. Does anyone have an AI problem that they want me to solve on the fly? No? Okay, I'll bring one up. Let's say what I want is I want a function that's going to extract a resume. So this is a BAML file. All you need to use this is a BAML file. You can use this in VS Code, in Cursor, soon JetBrains, NeoVim, whatever you want. You write a function. A function has, like in any other language, a name and parameters. A function can also return a data type. Your data types are described in code. But unlike every other language, your functions are implemented using a client, which is the model that you want to point to, and the actual prompt. And one nice thing is you can write test cases right below. And so you can see I have a prompt injection test case, and I also have just like a random resume test case. Now, this is where BAML starts to be different than any other AI framework. Right in your editor, you get to do something. You get to see your prompt right away. So before even running any of the prompts, you can see exactly what the prompt is. And we can do magical things for you. Like, for example, you can see that the resume from the actual input, which is the parameter from your test case, is actually highlighted because it is fundamentally different than your base prompt. So you can see parameters typed in. If you type in other stuff after it, it shows up in real time. So you can actually have a real-time preview of exactly what you're typing in. You can see the tokens that you're sending out to the model. And as you switch out models, the tokenizer changes. This doesn't matter for most people, but if you're really trying to get the juice out of the model, it matters. You can see the raw web requests that the framework is making under the hood, because at some point, we all know there's an abstraction layer. If I change this from OpenAI to Anthropic, you can see the web request changes. So it becomes an abstraction layer that has no abstraction, because fundamentally, we all know it's a web request. But the part where BAML starts to help out a lot more is not only can you see all these things, but you can actually run tests right here. So I'm going to zoom out a little bit. And you can just run the test. And you can see what happened here. I'm running a test case that was about the prompt injection. The model said, I'm sorry, I cannot fulfill this request, but because you encoded that you're returning a resume data type, we raise an exception, because that is not the data type that you wanted. Now let's run a different test. In this scenario, the model responded with something that looks approximately correct. It responded with a resume, and we converted to the resume data model. Let's add some fancy stuff here. Don't use quotes around keys. Caps did not work the way I wanted it to. Okay. So now the prompt is just this. Don't use quotes around keys. My string, as normal, I'm going to run this. Now you can see there's nothing here that has quotation marks, but the model still pulled it out. We did that using an algorithm that we created. This technique is called schema line parsing. It basically makes every model better without fine-tuning. You don't have to worry about data format. It just works. I'll show you what I want. For example, like let's say I want to return a resume array. Don't return an array. Let's try that. Okay, well, if it didn't return an array, we would just convert it to an array for you. You wouldn't have to think about it. We do all the error correction. No matter what the model says, we will guarantee that you get the data model that you typed out. And we do all sorts of weird things to make that correct, and I can show some benchmarks after this in a second. But I think the more interesting part is, okay, let's say you buy that this might be interesting. You might like this developer loop. At some point, your app's not written in BAML. We know that. So how do you go about this? Well, what you end up doing is you actually just make a file here. You have a Python file, and we export this BAML client, which gets auto-generated every single time you hit Command S or from CLI, and you get to do something really nice. Resume equals b.extract, and you can see it auto-completing along the way. Now resume dot, it's a list because I made this a list. Let's not make this a list. Resume dot email auto-completes. So you get complete type safety with all your data types. Your thing that was unreliable suddenly turns into a reliable pipeline of something that's going to return guaranteed a resume every single time. If you end up streaming turns this object into optional types. But when I'm done, it now becomes type safe again. So you can build experiences like what I was showing you earlier. Sorry, I was coding. You can build experiences like what I was showing you earlier over here, where the recipe generator is actually able to spin a loader spinner on exactly the field very, very easily. Now, not only does this work in Python, but because BAML is our own language and we can do a lot of control, we give you that same exact experience in every language of your choice. So in this case, I have right here. So result.email in TypeScript is a string. If I go back to my code from here, jump here, change email to be a string, I don't know, an int for whatever reason, my email code changes to be a number. And this mimics itself across every language. So we support around 15, 20 languages. We have around, I think 700 teams have now started using BAML in production. And the main reason that they really want to use us is because of this universal support for every single language and the ability to act as a model router along the way. So instead of building a model router as a proxy layer, you get a model router running in your native pipeline, in your servers, in your code, like you would write it with an if instead of as a middleman service. I'll pause really fast. Questions that someone wants me to touch on, or I have more interesting things to show. Yeah.
I actually just missed what you meant by model router, because I felt like you were showing just, this was, what is, when I think of switching between different fine tunes or whatnot.
Yeah.
So, yeah, what do you
point to any model of your choice. In this case, I changed this function to be switch over. I could also swap this over to anything else I've defined out here. So in this case, I have, let's use OpenAI fallback as the thing I want to use for this system. What does this do? Well, normally it'd be very hard to find, but the way you find out here is we just click on this thing and we can see exactly what it does.
So your statement of why people are picking it is because when they want to be able to switch between model providers
exactly.
while maintaining type safety.
Exactly. You get to swap between model providers with retry logic and everything else with type safety, with great debugging tools. And then the other part is this whole thing that I showed around like generating content. Let's use a more advanced schema I have. I'll use this one, Anthropic. So this one, for example, will allow me to actually run reasoning on generating medical data right out of the model. And you can see what the model actually does. The model does a bunch of reasoning, then spits out a data model that is not in any ways compliant in any way. This means that your cost went down because you're not using quotation marks as tokens. It means you're faster because you're not dumping a lot of quotation marks as tokens either, or any escape characters. and the model just dumps it out and we convert it exactly to your data model. So it becomes a thing you no longer have to think about. I can make any model a reasoning model because I just tell it to reason. And the prompt for this one is just this. I literally just said, before answering, list anything that is an anomaly we should take special note of. I said, this is the example of how I want you to list anomalies. It turns out this is a really, really nice way to make a model really good at reasoning. Because it doesn't force the model to reason in any specific way. It just tells the model, think if you should. So it basically becomes a replacement for tool calling for models that don't support tool calling right out of the box. I have more things to show, but other questions? Yeah.
Yes, so I don't want to give you a gotcha, but I just wondered about, is it possible at runtime to change the model and also additionally at runtime to change prompts?
Yeah. So you can also change prompts. Well, prompts can be changed by passing in parameters. Like you can pass in a parameter that says param. You can make it a string array, and then you can just say for p and param, dump out p. So you can go dynamically generate prompts and stuff with if statements or anything else that you want. But you can also change the actual data model. So let's mark resume as dynamic. Oh, what is this? Dynamic. Sorry, spelling is not my forte. And now in my test case, I can actually just say that the other thing I want is, and you can also do this from Python as well, dynamic class resume. I don't know, what's the other thing I want in here? Let's see. I'm going to get rid of this param thing. Break my test case because I did not write that. So in this case, like I have all these things. Maybe I want to have like programming languages. So now you can see at runtime, this is actually going to add programming language just for this one scenario. So we have people doing classification problems with over like 70,000 categories using BAML dynamically and getting high accuracy. We have people reading bank statements from PDFs that are able to process 100-page plus PDFs with 0 cents of error at the end of their pipeline. Before this, they're paying Oculus like $7 million or something a year to process all this data. Now they brought the tech in-house, so they don't have a vendor dependency. They're able to manipulate it to exactly what they want, and it costs them less than 100K. The key part is what I was saying earlier in my slides. What you really want to make these models good is you want less prompting and more engineering. Because when we can make the diffs really good, when we can make the engineering workflows for your team really good, and you can make solid API contracts, you can build a system that won't break. And that is the magic of AI. When a customer can actually feel trust in what you have built and feel what you have built is not going to screw them, or you're going to show the right context at the right time, and you make it easy for your engineering team to do that work. If they have to plumb 7 layers of data from every who knows what to all the way to your UI, they will not do the work. Make it easy for them to do the work. We've got a pretty fun team that's been building this out for over a year and a half now. And that's my LinkedIn, and that's our GitHub repo. All that, what I showed you, is complete open source, built in Rust, so it's really fast. Give it a star. I have to ask. It's part of my job. But if you are curious about anything, love to answer any questions or do any sort of, while I answer questions, I'll show one last thing. These are the benchmarks on how good the structured data is. Zoom in. Okay, that didn't work. So BAML with GPT-3.5 with the parser that we wrote, it's called schema line parsing, will outperform GPT-4o with structured output. And to give you an intuition about why this ends up being really good and why that makes sense, I think the best way to think about this is structured outputs or any other technique that models use today are all about producing JSON data. Well, could you imagine trying to ask let's ignore LLMs, asking a human to write this code? It would be impossible. Like no engineer, we have a senior staff engineer from Google here, and if we had to write the code in JSON mode, he would struggle. It turns out this is just a more elegant way of writing code for the model and for humans. If you limit it to JSON, the model has to do this. It just can't be as good. It's not in its distribution. And it won't ever be in its distribution. There will always be more data that matches this. So what we say is we let the model output this and we pull out this without you doing a single line of code. What that ends up looking like is, do I have something? Let's do this. I want to take user query and generate Python code from it. So what this thing will do is something similar to what you're seeing at the very beginning of my demo, where I take a user prompt and actually generate BAML code that describes it. And not only do that, I generate code that also runs, that also describes exactly what that is. So now I can copy and paste this. I could run it there as well, but I'll just paste it here. I can just paste it here. I can open the playground, I can run the test and see if it works. And you can see exactly what the model did. Without any prompting, the model wrote the code in a triple block string, because that is how you write Python code. I didn't prompt it, I didn't force it, just did it naturally. That is the highest token value that the model could have done. But BAML pulled it out, and now you have the right code right here. You didn't have to do any work for it at all. Questions? More?
Escaping over there? Is that just because of...
No, the model actually generated some escape characters. It chose to do that. And you can see our parser chose to preserve those escape characters. The point is models are random. If the model hadn't dumped these, it would still work, because the parser is really, really good.
Do you think you can optimize the prompts that people write? Like
Yeah.
I write the extract resume function and I have a prompt, but maybe I'm just not good at writing the prompt.
Yeah.
Can BAML, do you think that's possible, or do you already do this?
We have experiments that do this. That's kind of what the chat AI. So the question is, can we optimize the prompts automatically? It turns out it's way easier to optimize these prompts, because instead of a giant hoobly-goo of English that we normally see in prompts over here, you actually have prompts that are both easier to read for the model and for humans. So like I can see that, hey, this name field right over here is exactly what it is as a human. So if in my data sources, in my observability platform, I see that, hey, medication.name was wrong pretty often, I know exactly what I have to do as a developer or as a automatic prompt optimizer. I update this text, nothing else. So yeah, it becomes possible. And we have some early prototypes that show that it works pretty well.
Maybe one more from me. So I think this is great examples of essentially data extraction pipelines. And
Yeah.
I think that I could see why 500 teams would absolutely want to do that. If you think of it this morning when I was sharing these investigative scenarios where we have to do a bit more reasoning and kind of more like the agent is in control of the loop, I'm just curious if you have any thoughts on kind of the accuracy and quality for kind of more of that stuff.
I have lots of thoughts on agents. I'll show you the most of it. So we've run a bunch of prompt engineering workshops for like a bunch of YC founders. We had like 350 or so YC founders go through them. But I think this is just a misconception that a lot of people have about agents and prompts, because everyone is trying to lock you into their API. You to use their agentic framework, because then you can't move to Anthropic. I wouldn't want to do that, because the models get better all the time. I think if we just change how we think about LLMs, it becomes a lot better. Instead of thinking of an LLM as this magic thing, just think of it like a function. It takes in inputs and spits out outputs. So you have a thing that's going to return one of three categories. Now a tool call, therefore, becomes a thing that spits in inputs and spits out one of multiple data models. It's just a union. We know how to deal with unions. We have a lot of UI code that deals with unions in the future already. It works really, really, really well. Now, then an array picking multiple tool calls, or parallel tool calls as they call it, is just an array of unions. It's just a one-line diff. The calling code is also a one-line diff. Instead of saying action, go do this, you just say for action and actions, and check what in and go write the code. It becomes a lot easier to go manage. You don't need an agentic framework. You get a lot more control around this as well. Now, if you're building an agent is just a thing that takes in a state, somehow creates a prompt from that state and returns some. And then, and this is a more advanced version of it, but when you have a starting state, you have a while true statement, and you build some evictions conditions out of it, and you just say, based on this, I just keep on adding data into my state and looping around. That's all these agent frameworks do under the hood, but you just have a worse agent framework, because it's like building a website with Bootstrap. Every website that's built with Bootstrap looks like it's built with Bootstrap. It is It looks exactly the same. And there's a reason ShadCN, for those of you that don't know, is a UI framework that is predominantly won out in all systems today. Works really well. Because UI frameworks don't work if I just use the library, because I need to modify it for my system. It's really important I can go do that. What ShadCN does is, instead of being a library that you install, it is a package manager that downloads components directly into your code base. So if I am like at Splunk and I offer an MCP server, it's very true that the MCP server that you guys need at Graphistry is going to be slightly different than MCP server that someone else needs. So you'd be much better off just downloading their base prompt and using that initially, and eventually having access to modify it to your specific needs. Otherwise, you're stuck in a world of hurt where you have to go file an issue and you're stuck with an 80% scenario. And no one wants 80% with AI. AI with 80% is just garbage. Sorry, that was a very strong statement, so maybe I shouldn't have said that. But AI with 80% is not that good. Yeah, it was a pleasure to be here. Thank you guys for listening.